Okay, I need a motion to adopt the agenda.
Move approval.
Oh, actually, I need a roll call first. Sorry. Jump the gun there.
Director Bragman,
Here.
Director Gibson,
Here.
Director Kohler. You're on mute.
Sorry, here, I'm definitely here. Mhm.
Vice Chair Schmidt
Here.
and Chair Russell.
Here. Okay, now I need that motion. We actually got that motion already for adopting. I just need a second.
Second.
Roll call.
Director Bragman,
Aye.
Director Gibson,
Aye.
Director Kohler,
Aye.
Vice Chair Schmidt,
Aye.
and Chair Russell.
Aye. Okay, public comment on any items not on the agenda.
There are none.
Okay, that's cool. I need a motion to adopt the minutes.
Move approval of the minutes.
Second.
Roll call.
Director Bragman,
Aye.
Director Gibson,
Aye.
Director Kohler,
Aye.
Vice Chair Schmidt,
Aye.
and Chair Russell.
Aye. Okay, item 2, East Blythedale Avenue Pipeline Replacement Project.
Hi, good morning, directors. Crystal Yesman, Director of Engineering. Before I hand this off to Zach, I just want to give you a little background on this project. Mill Valley is doing a renewal project on Blythedale. As you know, they completed the big one over on Miller Avenue. And so now they're moving their sites to Blythedale. And this is one of those projects where we're quite sure if we should replace the pipe, because even though it's really old, and Zach will go into the details on it. But when we started doing potholing for the project, we found out that our pipeline was too shallow. It doesn't meet the engineering standards for depth. And so when they go to redo the road, there's a chance of vibration and damage to the pipe. So we do need to lower the pipe. So since we're going to do that, we might as well replace it as well. So it's an unbudgeted project, but we do have budget in the CIP. We're going to move some projects around so we can make it happen. I think everybody's happy in the end because Mill Valley will have a new improved roadway and a new pipe on the road as well. So I'm going to pass it over to Zach and he'll give you some more detail on the project.
Thanks, Crystal. Hi, good morning. I'm here to present the East Blythedale Pipeline Replacement Project. It's in the city of Mill Valley, as Crystal has mentioned. The project will install approximately 5,500 feet of PVC and welded steel pipe to replace a 100-year-old cast iron pipe, which was installed in 1921. The project is in coordination with the City of Mill Valley Street Overlay Program, and I've been working closely with their engineering department. My engineer's estimate for this project is $2,100,000, and bids will open January 11th. The project is scheduled to last 180 days with completion date of July 31st, 2022. If all bid documents are acceptable, staff will make recommendation at the February 1st board meeting for contract award. The recommended action is for review and referral to a future regular bi-monthly meeting of the Board of Directors, with the Operations Committee recommendation to proceed with the project.
Mm-hmm.
Can you tell us a little bit?
And the
more?
good
So
part now, it
sounds-
won't freeze either, huh? Because we're lowering it.
Right.
Yeah.
So it sounds like
Joke.
an important and obviously worthwhile project. Zach, can you tell us a little bit more about your coordination with the city? It sounds like that's gone well. I just want to hear a little bit more from you about how those conversations have gone. Everybody's good about who's paying for what.
Yeah, we're still in permit conditions negotiations right now. We were going to do a joint project, but the city, they weren't ready to get into a joint project, but they really want us to still go ahead with the project because we need to lower the pipeline, and they are expecting to start somewhere after us, and we're coordinating heavily on where we're starting, which direction we're going, because they want their contractor to do the same thing, so we don't meet in the middle. And we've been in communication with them constantly throughout the process, and we're expected to start sometime in early March with this current schedule, and they should be sometime maybe a month or two behind us, so that way as we're moving along with the pipeline, they're going to be moving along with their paving contractor.
Thanks.
So,
Any,
go ahead. Sorry.
no, I was gonna ask any other questions.
Oh, how deficient is the pipe as far as the depth of its current location?
Oh, what's its current depth?
Yeah, versus what's required.
So their street, I don't know if you've driven, most of us have driven down East Blithedale, but there's a big crown in the middle of the road.
Yeah,
You kind of
yeah,
feel
yeah.
like you're riding up a little higher. So they're actually lowering the majority of the road by up to 6 inches. And it's AC on top of a concrete. And they're actually going to bring it all down 2 feet and then build it all back up. And then the final grade will be about 6 inches lower than it currently is throughout most of the length of our project. So when they go down 2 feet, they're going to be right at the edge of where our existing pipeline is right now, maybe within 4 inches. And so our new pipeline will be installed 36 inches below current grade. So we'll have sufficient cover when they go down and take the old road out and put the new road in.
Yeah, so it sounds more like they are causing the replacement more than it's really not at the correct depth, really.
Well, actually, no, Director Bregman, that was our original stance, was that, hey, you're lowering your road
Right.
level, so it's on you to lower our pipe.
Yeah, yeah.
And but we did some potholing and we found that our pipe is only 2 feet deep in some places, which doesn't meet the standard for 3 feet deep.
Yeah,
So
yeah.
it was
Okay.
already too shallow, our pipe. So we,
Yeah, okay, okay.
if they were, so we need to lower the pipe. So yeah, but originally we're like, well, you're
Crystal-
lowering the street. So,
Yeah.
but it turns out our pipe was too shallow to begin with.
Okay,
Crystal-
well, maybe I didn't follow your Zach's calculations there, and it may vary too. So the other thing is, did anybody test the soil? Because I know when we did the trenching on Drake, it turned out it was contaminated, probably with lead and all kinds of stuff from the cars. So I think Blithedale is one of the most heavily trafficked roadways in Marin. So any idea if we're going to have to pay for that kind of cost on this thing?
We have not tested the soil. When speaking with the city, they have not mentioned contaminated soil. We are asking for a contingency on this project just in case something like that does come up with
Yeah,
with
well,
what did happen on Drake. But as of right now, no one's, because they've done a lot of East Blithedale from Camino Alto to the US 101, and they have not mentioned anything.
okay, well, that's good. And then the last thing was there's a good discussion in your report about recycled water and the proximity of, I guess, Southern Sewer Agency of Southern Marin. Is that
SASM. Yes, SASM.
so? Do they have a recycled water plant there?
They do
Well, they have-
recycle water, and they have about 36 acre feet a year. If you look at the report that
Yeah,
they're
yeah.
delivering.
But
Yeah,
they're-
they do have recycled water, and the master plan that was developed with us in collaboration with Marin Water and SASM, the recommended preferred project was a recycled water pipeline heading south to Miller Avenue to the high school. And so that's away from our project. So
yeah,
that was the preferred project.
you could probably get the golf course this way.
Yeah, you could.
So
It might be closer to go a different way, different route though, to get to the golf course.
I don't know. Well, I'm kind of actually just guessing. So does anybody know?
If I could add maybe just a little piece of information, the recycled water that SASM produces is grandfathered. It's not tertiary recycled water like our water, so it would have very limited uses for new applications.
Yeah.
The recommended project.
It's more like swamp water.
Are they?
Comes out of a pond.
Oh, nice. Is there any plan for them to, renovate the recycled water down there? Or is that?
Paul, sorry,
Go ahead, Crystal.
I'm sorry, I did go online and look at their most recent master plan that they just published in their CIP plan. They just issued a 10-year CIP plan. And it references our recycled water master plan from 2014 or 15, but it goes on to state that this recycled water project is not funded and will require, investment from Marin Water. If, so
Yeah,
there's
yeah.
right now, there's nothing on the table for an investment, but they still have it listed in their CIP plan that this is a project, that's been
Yeah.
identified as preferred. So
Yeah, it sounds pretty attenuated at this point. So, well, those were my questions. You've shot down all of them successfully. So,
Did we consider? Go ahead, Ben.
Just very briefly, it didn't come up, but it's in the report. This pipe was installed in 1921. It's cast iron. So regardless of the depth issue, just for anyone listening, this is a very good advancement of infrastructure renewal.
I agree, and that's why I haven't pushed on doing a concrete cap, because that would be the other way to get around this problem, right? Just put a cap over it and go on about your business. But with that 100-year-old pipe, it's probably reached its life.
yeah.
I
Amazing.
just want to ask one question that's sort of, I mean, it's obviously an important project. We got to do it. Just a question in terms of cost. How have we seen a significant increase in the cost of construction related to COVID and other, related infrastructure supply impacts? That out of curiosity.
no, that is a good question, Monty. Worth looking into. I'd have to get back to you on, engineers' estimates, 3 years ago versus today. But I don't have that data.
Yeah, I think
No worries.
across the industry,
thank you.
it's pretty competitive, Monty, right now. Guys are still licking their wounds from the COVID time, and the numbers we're hearing about have to do with materials and the supply chain issue more than they had to do with labor. So I would expect to get a pretty good bid on this one.
Mhm.
Okay, I need a motion to refer it to the board. Oh, any public comment? Public comment? Hang on one second.
There are none.
Okay, now I need that motion to refer it to the board.
I'd move it.
Sorry, I'll make that
Okay.
motion.
Sorry?
I'm sorry, I was muted. I said I'll make that motion.
That's
Okay.
fine. That's fine.
Oh, does somebody else? I'm sorry. I
No, go ahead. You got it.
It's
That's
no
fine.
problem, no problem. It's your home
That's your
turf, it's
district.
fine.
don't think it matters.
Okay, good. It doesn't matter, no, thank you. Okay, let's move on, Crystal, to the next one.
All right.
Kastania.
Kastania pump station update. Before I hand this over to Mark Cazaret, our new engineering manager for construction, I just want to relay my appreciation to the folks that have been out there in the pouring rain, slogging through the mud to get this project done, as quickly as possible in order to take advantage of flows from the north. But with that, Mark and I have worked through the presentation he's going to give, and I'm going to pass it over to him, and he's going to PowerPoint to you.
Before we do that, I think we should give some thought to changing the name of this pump station. Ben, before your time, we tried to get the street in front of the office changed to Seeger Way. I think this might be a nice thing to change the pump station to the Bill Seeger Pump Station or something like that. Just food for thought. Okay, I'm ready.
Okay, all right. Well, thank you, Director Yasmin. Good morning, board members. Mark Cazaret, Engineering Manager for Construction. Today, I'll be providing an update for the Kastania Pump Station project. Okay, so the presentation today covers a brief background and history of the Kastania Pump Station. I'll go over the hydraulic improvements that we expect to see from operating this pump station. I'll recap the agreements necessary to transfer the property as well as operate the pump station, and then share our progress in construction and some photos. And we'll conclude the presentation with some accomplishments and next steps. So the image on the right shows Kastania Pump Station. It's located in southern Petaluma with Highway 101 to the east and Kastania Road to the west. So built by Marin Water in 1977, the pump station is about 1,200 square foot. There is essentially 2 rooms. One of them is on the right side. It's got a taller roof. It's the electrical and control room. Houses the electrical equipment as well as telemetry equipment for Sonoma Water, North Marin, and Marin Water. The pump room has the shorter roof. It's mostly below grade and houses 2 pumps, valves and miscellaneous appurtenances, and the discharge header. The pump station was originally built to increase pressure and flow through the North Marin Aqueduct. And we owned and operated the pump station for about 22 years, from 1977 to 1999. In 1999, we transferred ownership to Sonoma Water, who owned and operated it until 2015. And the pump station was then taken offline in 2015, following the completion of the North Marin Aqueduct pipeline relocation project that relocated approximately 4.5 miles of the North Marin Aqueduct. And this relocation project was done in conjunction with the Caltrans highway widening project. So the photo to the right shows 2 pump sets, pump number 1 and 2, the pump control valves, and of course the discharge piping. Currently, only pump set number 2 is anticipated to be operational, and we're aware that the motor for pump set number 1 requires refurbishment or replacement. So during the design phase of this project, we modeled the hydraulics for the North Marin Aqueduct, and we looked at both with and without Kastania pump station in operation. So this slide shows that the water flows available to the district earlier this spring, when North Marin was filling Stafford Lake, provided about 15 million gallons per day. And again, this is without Kastania pump station in operation. So with that, North Marin was drawing, or their demand was about 11 million gallons per day, which left about 4 MGD to Marin Water. So this slide shows Kastania in operation during this same time frame, and the total available flows to the North Marin Aqueduct increased from 15 MGD to about 21.5 MGD. So without Kastania in operation, the water available to Marin was about 4 MGD. And so with Kastania operating, Marin sees an increase of about 6.5 MGD. It is important to note that under this current scenario, the capacity of our internal distribution system actually becomes a bit of a limiting factor for how much water we can receive. And so given this capacity limitation, our district staff are evaluating additional internal system improvements that can help us reach our total contractual allotment for imported water supply from Sonoma. We're actually looking further into system improvements to achieve greater flows from our imported water should a winter water concept come to fruition. And so with Kastania in operation, it affords us about 12,500 acre feet per year, which is about 1,800 acre feet shy of our contractual allotment. And so this averages out to a need of approximately 1.6 million gallons per day. We will be coming back to the board in January or February with results of hydraulic analyses, as well as some recommendations for CIP projects to help address some of these bottlenecks or system deficiencies. Okay, so we're approaching kind of the construction update, but to give a quick recap, in order to recommission the Kastania pump station, there were 3 key agreements required between Marin Water and North Marin Water Districts and Sonoma Water. Starting with the transfer agreement, this provided the property transfer from Sonoma Water to Marin Municipal, and also the subsequent conveyance of easements to North Marin and to Sonoma Water so that they could access their assets within what will be our property lines. Next is the interconnection agreement. It provides for a basis where the district and North Marin can continuously meet the needs of their respective customers while utilizing our capacity and our distribution systems to benefit both districts. So essentially, this document recognizes that there are a number of interconnections between our two systems, and that the way we operate our facilities can impact the water flows in our neighboring jurisdictions and vice versa. And so this document governs wheeling or the transfer of water between the two distribution systems, as well as the cost for that. The last agreement is the Operational Memorandum of Understanding, or the MOU, and that essentially documents an understanding between the three water districts, but also the city of Petaluma for the specific operation of Kastania Pump Station. It essentially governs the conditions by which Kastania and nearby facilities can turn on and off. So it's more of a document for specific operations. So all three water districts and the city of Petaluma worked very closely, very collaboratively to develop and complete the agreements needed for the district to recommission the pump station. On November 2nd, Marin Water and Sonoma Water Board of Directors authorized their general managers to execute the transfer agreement. On December 7th, North Marin Water District authorized their general manager to execute both the transfer agreement and also the interconnection agreement with Marin Water. And so we're currently finalizing these documents for signature and preparing the real property contracts or documents. I'd also like to take this opportunity to thank our partners at Sonoma Water and North Marin. Their diligence and support of this effort in a short time frame to get our pump station recommissioned here is greatly appreciated. Okay, so now I'll provide a brief update on construction progress and share some photos, and we'll conclude the presentation with some of the many accomplishments of this project and next steps. Okay, so this is a slide showing our yard piping plan. It's actually a civil drawing from our contract documents with the contractor. And I'm gonna try to orient us a little bit here. So here we have Kastania Road, and it's west of the pipeline of the pump station. And this is the driveway that comes into the pump station. Highway 101 is to the west, shown at the bottom here. The original North Marin Aqueduct traversed, the alignment traversed along Kastania Road, south towards Novato. The North Marin project that relocated the pipeline turned the aqueduct and traversed through what will be our pump station property under Highway 101, where it would then transfer south towards Novato. So originally the pipeline went down Kastania Road to Novato, and now it comes and goes under Highway 101 and then continues south towards Novato. So as part of our project, the first step was to disconnect the old discharge piping of the pump station from what was the old North Marin Aqueduct. And that's located over here. So that was our first order of business. We successfully isolated the existing pipeline. Next, we installed roughly 200 linear feet of 30-inch welded steel discharge piping in preparation of connection to the new North Marin Aqueduct. We also installed two 30-inch butterfly valves on the pump station suction piping, and that's located here. And probably one of the more important phases of construction was a hot tap of the North Marin Aqueduct. And I'll describe what a hot tap is a little later. So the pending steps in construction we have remaining are pressure testing and disinfection of our new pipeline, as well as tie-in or connection to the North Marin Aqueduct. And this is the point at which we're fully connected and mechanically prepared to move water. The last step of construction will be electrical testing and then pump station startup. Okay, so this slide shows removal and replacement of the 30-inch butterfly valves at the pump station suction piping. This is a relatively low-cost assurance that we can reliably isolate our pumps due to the need for repairs or maintenance. This We essentially felt that it was prudent to replace these valves as part of this recommissioning effort because it's a good insurance policy. Okay, so here on the left, we see the preparation of the pump station discharge piping. Again, it's 30-inch welded steel. It connects the discharge side of the pumps to the new North Marin aqueduct. And then on the right are the final connections to the suction piping for the butterfly valves. So this slide shows the first step of the hot tap, and this is the installation of a 42-inch wrapper plate, or essentially a sleeve that wraps around the existing live water main. And so the hot tap allows the contractor to provide a new point of connection to the existing pipe that's already in service without any disruption to water customers. And so in the photos, we see the wrapper plate getting installed on the right, and then welded and permanently fixed to the existing pipeline here on the left. Okay, and here we see the hot tap in progress. That's on the left here. And like I said earlier, it begins with the installation of the wrapper plate or the sleeve, and that's shown back here. The next step requires installing a gate valve. So we needed to install a 30-inch gate valve, which bolts onto the branch connection of the hot tap wrapper plate. After the valve gets installed, the machine is ready to be bolted to the backside of the valve. And so the machine gets lowered into the trench or the pit and gets bolted. And that essentially prepares for drilling. Prior to drilling, though, we need to pressure test. So we performed pressure testing to ensure that there was no leaks to the butterfly valve, or I'm sorry, the gate valve, or the wrapper plate. So then the machine begins operating. There's a drill bit, a 30-inch diameter drill, or 28-inch diameter drill bit that drills through what is the open gate valve into the existing main. And this process for this size takes about an hour and a half. Once it cuts through the main, it then gets retracted, and then the gate valve closes. And once the gate valve closes, the machine can depressurize and get removed from the pit. And we essentially have a point of connection ready to go. And so the photo on the right shows the removal of the machine and the cutting bit, and you can see the coupon is safely within the cutting bit there, which indicates a successful hot tap. So this was a big achievement for construction. Okay, so just to recap or to provide a few accomplishments, we began this project in February, and we've made significant progress towards commissioning this pump station. There's been a lot of parties working tirelessly to tie in all these needs, both from a construction standpoint and also from a legal standpoint. We finished design and the hydraulics modeling in October. And from the time the design plans were stamped, October 12th, we advertised for construction just one day later on October 13th. We started construction with a notice to proceed not even 1 month later on November 9th. We've completed the pump station agreements, and they're effectively ready for signature at this point. Thanks in no short part to our legal counsel. We've completed over 80% of the construction work, and this is no small feat. Multiple crews were working simultaneously, working into the night, and also working during weekends as well. So significant resources were expended to get this pump station ready for commissioning in January. So some next steps would be completing the right-of-way acquisition of the pump station. We anticipate issuing notice of substantial completion in the first week of January, though we do have some upcoming rain that may impact construction operations. Because of the progress we've made in construction, we've also decided to pursue a contract change order for the removal of that pump number 1 motor. So you'll recall pump number 1, the motor is anticipated not to work and require refurbishment or replacement. So due to kind of our progress, we decided to pursue a change order to pull the motor and get it repaired or replaced and reinstalled with this current contractor that we have. And that will allow for hopefully full pump station operation and redundancy into February of next year. So this was a two-phase project. We plan to begin phase 2 improvements, and this is going to take on a traditional CIP delivery. And this will be for replacing our outdated electrical distribution and motor control equipment, as well as various civil improvements that will ensure reliability of the pump station for decades to come. And once all said and done, and we transfer the PG&E power meter over to Marin Water accounts, we will be pursuing converting the energy production to 100% renewable sources through Sonoma Clean Power. And that concludes the presentation. We'll be happy to answer any questions.
That was a great presentation, Mark. A very interesting update. Is that a diamond drill bit they used to cut through?
You know, I'm not sure, but I was very interested. I did take lots of photos, and to me, it did not look like a diamond drill bit. It looked like just like a hardened steel, and it had 3 teeth, you know, that in 3 different directions. So one tooth cut kind of one edge, another tooth cut another, and then there was a center that kind of created a nice groove. So you may recall seeing the coupon. It's a very clean cut with minimal kind of debris that comes off that.
Yeah, it's a circular hacksaw, huh?
Pretty much, that's what it looked like to me.
Just a minute. Can you stop the screen share so we can see each other?
Oh, I'm sorry.
That's okay. Thanks.
Yeah, one moment here.
There we go. Thank you.
Mhm.
I want to congratulate Mark for a great presentation there, but also the team that's working on it. I mean, this is really quite an impressive project. Larry Russell suggested we should call it the Seeger Pump Station. I think we could come up with a whole bunch of candidates whose name justifiably be put on it. Sounds like you got a very successful team here.
Thank you so much, Director Gibson.
Yep.
Mark,
And I agree with you, Jack.
Yeah, and I agree. I thought it was a fantastic presentation, and thank you for making it so clear for those of us who are not engineers. I appreciate that.
Yeah,
So I have kind of a historic question. And I'm sorry, you may have mentioned this, and maybe I should know, since I know we've been talking about this project for a while, but can you remind me, you know, what was the historic reason that the ownership transferred and is now transferring back? I just don't have my arms around that history. I just think it would be helpful in thinking through where we might be going with this.
That's an excellent question. I think I may have to defer to perhaps one of the directors if they know. I know we own the property. We built and owned the property for 22 years up until about 1999. But after transfer of the property to Sonoma, it remained in operation for another 16 years. It might have been due to just operational simplicity, but at this point, that's kind of speculation on my part.
Okay, it's not a big deal. I just know that we're planning on doing more, so I just want to make sure I understand the history there.
Oh, certainly.
Yep.
I have heard, oh, Crystal, you go ahead.
No, I also don't know. So Ben or Paul probably.
Well, what I have, right, this is kind of rumors, but I'll share, not rumors, but, you know, third hand, that one of the reasons we were interested is there was a big power bill, and why would we pay that power bill versus it being part of the system? So Sonoma was game to take it on, and, you know, so that was at least one thing I understood why we would give it up, because that was the question I asked.
Yeah, I think you're right, Ben. That's kind of what I recall. The power bill, as I recall, was like $400,000 a year. And I think you're correct. Although, I don't know, Jack, have you ever heard a direct discussion of that? It predates us by a long, even predates Jack by a long way. So
I can't say I have any recollection, no.
Dana would know, and Ron Thyssen would know if we want to find out. Those two could figure it out.
And I also want, oh, I'm sorry. I also wanted to just reinforce, you know, the obvious from the early slides in the presentation, that this is a key project to improve our water resiliency and our drought response long into the future. So I really, as well, am so appreciative of the support we got from Sonoma, from North Marin, and the work Crystal and Mark have done, along with Mike Bond, who really got this going initially. So really great work, and I'm not going to say surprising how quick it was done, but quite notable and impressive on the speed.
Yeah. And I join. I mean, it really does epitomize sort of the totality of the complexity, from the agreements to the mechanical to everything. You know, it was a really great presentation, and it is, I think, a key accomplishment. I really do.
Well, and the other thing to keep in mind, had it been thought of sooner, it could have eliminated the whole desal pilot work, because the desal plant is smaller. The proposed desal plant back in the 2000s is smaller than the flow advantage that comes from this one, assuming you can get the water from Sonoma.
Could I
Kind of
ask
interesting.
could I ask a basic question? So this increases our ability, the amount of water we can get from Sonoma, correct?
Yes.
Absolutely.
So is it the same water that's currently flowing in the aqueduct, or is it, so I'm, you know, how
Yeah,
is
so we get our water, we use the North Marin aqueduct. And really what we're doing with this is just adding pressure to that aqueduct that increases the capacity rather significantly. So not only on an annual basis can we get our full allotment, or we're headed there, we also can get water when we need it and move it when we need it, and have the operational flexibility. So it's really is significant, both operationally as well as, of course, from a water resiliency.
Okay, so could I ask another mechanical question? So are the pumps, are they literally just increasing the pressure that's going into the North Marin aqueduct?
Yes.
Wow.
So they're forcing more water through the straw.
Yeah.
Larry, basically.
Yeah. No, it's
But,
a really good presentation, and, you know, very clear and helpful too. So really
Thank you.
appreciate that. Yeah.
Okay, any public comment?
Yes, Paul Duder. Go ahead.
Hi, yeah, I was just kind of curious about the power requirements, and just in general, how it is that we work with PG&E and MCE to bring on that extra capacity when we have a project like this that needs new power.
Yeah, so let me just address that briefly if I can, Director Russell. The
Sure.
power is not Marin Clean Energy. It's actually going to be purchased from Sonoma Clean Energy, because it's outside of Marin County. But it will be 100% renewable once we get the meter installed for electrical supply.
Now, this project had the power there from the prior operation. So often, you know, it's quite an effort and costly to bring the power, or this a new pump station. But this was really hooking up the available power and then negotiating with the Sonoma Clean Energy.
But my understanding is that when we need, or if we desire clean energy, we need those entities to basically build new capacity. Is that not right? There's got to be a new solar farm somewhere in California.
No, they just buy new capacity.
Yeah.
I
On the
believe
market.
that Sonoma Clean Power gets a lot of its green energy from not just solar, but I think also the geysers up in Sonoma and Lake
Oh
County.
yeah. Another amazing project. Really.
Yeah.
There's no obstacle, because in some of the other projects, one of the things that's been called out is the lead time that we need in order to bring on new capacity.
Right. So, well, you go ahead, Crystal. you know,
Yeah.
if, well, go, you go.
Okay, yeah, so for those projects, there isn't an electrical connection already in place. And so to bring in the power requires new poles, transformers, switch gear. I mean, so, and it takes a while. A transformer, lead time on a transformer is, 12 weeks at a minimum. And so, but in this case, all of that equipment is already there. So, and we're already connected.
And the other thing, what they do, the Sonoma Power, Marin Power are not generating their own clean energy. So in a sense, they're going out into the clean energy market, and you're kind of making transfers of credits, of clean energy credits, and you're kind of encouraging capacity that's out there that may be unused. So it's the agency itself is not generating its own power, although they do have some of those projects, I'm sure, ongoing, just like Marin does.
Well, okay, so yeah, that's what I kind of expected. But when I've been reading documents on other projects, what I've seen is there's an obstacle to getting clean energy. In other words, some projects need to be powered with energy that might, have greenhouse gas emissions. And that seems to be, a negative about those projects, that we cannot bring on clean energy. And what I'm hearing now is that if we have, the transformers and everything, then we can get clean energy. We just have to buy it.
Yeah.
I don't quite understand the disconnect then with other projects that have to be, non-clean energy.
They may not have a clean energy provider, and certainly, when the sun goes down in California, the agency is buying clean energy elsewhere. I mean, it's really, I don't know if arbitraging is the right word, but.
Well,
I think it is.
Specifically, I was looking at the documentation for some of the desal plants, and how one of the negatives was that they wouldn't be able to be powered with clean energy. And I'm just trying to understand why.
Yeah, you're right on, Paul, but recall that this is an ongoing project. So somebody, Sonoma Water, has been paying a standby charge. There's already capacity allocated in the system for this facility because it was an operating pump station. And for whatever reason, Sonoma Water kept paying the power bill all the way through. So there was always power available, and which means they were paying some kind of standby charge to PG&E or to Sonoma Clean Energy to keep the power there in the event it were to be needed, which is kind of strange because it couldn't be used, but they paid it anyway.
And the other thing, and not to jump off the deep end on this, is, PG&E is, I assume, is going to get some payment for its distribution costs. So they're separated.
Oh, yeah.
The generation is separated from the distribution costs. So
Yep.
PG&E, it's sort of a two-phase kind of deal.
Yep.
Thank you.
Great. Thank you, Mr. Duder. There are no further comments.
Okay. Well, thank you for the update. With that, I think mosey on.
Good news.
Yeah, thanks
Yeah,
everybody. Have
thanks
a
a
good
lot.
holiday.
Yeah,
Thank you.
got it. Yeah, happy holidays to everybody.
Yeah,
Hey,
all good.
Enjoy.
We'll see you soon.
Okay,
Thanks
cool.
a
thank
lot.
you all.
Take care. See y'all.